This video covers Chapter 9, which is producing data in experiments. So in this chapter, we're going to cover observation versus experiment. So what's the difference? The subjects, factors, and treatments in experiments. How to experiment badly. We need to learn how to do something wrong so we can always do it right. Randomized comparative experiments. The logic behind having a randomized comparative experiment, and some cautions about experimentation, as well as matched pairs and other block designs. In contrast to observational studies, experiments don't just observe individuals or ask them questions. They actively impose some treatments in order to measure the response. So most surveys that you take, I think all surveys, are observations, but experiments always have some type of treatment and they want to measure the response. Note that this treatment is not necessarily medicine. It's not always medicine. We could be asking people to read for 10 minutes a day or to listen to Mozart while they're doing dishes to see if they do the dishes better. That was a silly experiment, but there have been sillier, I'm sure. So an observational study observes individuals for measures and variables of interest, but it doesn't attempt to influence their responses at all, right? It's just to describe a group or a situation. An experiment deliberately imposes some treatments on individuals and observes their responses. The purpose of an experiment is to study whether the treatment causes a change in the response. Note, that treatment is not always medicine. It doesn't necessarily have to be medicine. So when our goal is to fully understand cause and effect, experiments are the preferred source for fully convincing data. So in this example, let's identify the study as either an observational study or an experiment. So a poll in which college students are asked if they commute or live on campus. Well, that would be observational because we are not changing their outcome, right? A medical study designed to test whether large doses of vitamin C prevent colds. Well, test large doses of a specific vitamin, right? That's going to be an experiment. What about a study where adults' BP is taken when listening to various genres of music? By BP, I mean blood pressure. So we might have them listen to some heavy metal, maybe some hip hop, maybe some Mozart, like I mentioned earlier. But even though it's not a medicine, this is an experiment because we're giving some kind of treatment and looking for a response. So an experiment is a statistical study in which we actually do something. Like I've said, we apply a treatment to people, to animals, and we observe the response. So here's the basic vocabulary for experiments. First off, the individuals studied in an experiment are often called the subjects, particularly when they're people. Sometimes they're called participants as well. The explanatory variables in an experiment are often called factors. So what factors are we looking at? A treatment is any specific experimental condition applied to the subjects. If an experiment has more than one factor, a treatment is a combination of the specific values of such factor. So the remedy for confounding when it comes to experimentation is to perform a comparative experiment in which some individuals receive one treatment and similar units receive another. Most well-designed experiments compare two or more treatments, and some experiments include a control group, right? That receives an inactive treatment called like a placebo. That is not actually the treatment. It's a fake first treatment, or have an existing like baseline treatment. An experiment that uses both comparison of two or more treatments and random assignment of subjects to treatments is called a randomized comparative experiment. Comparison alone isn't always enough though, right? If the treatments are applied to groups that differ greatly, bias will result. And the solution to the problem of bias is going to be randomly assigning our participants to their groups. In an experiment, random assignment means that individuals are assigned either groups at random, and it's through some like chance process, right? So in a completely randomized experiment design, all the subjects are allocated at random among the treatments. So we've got our people who we're going to study. We assign them randomly to group 1 and group 2. They get 2 different treatments, and then we compare the results. In order to determine if a treatment works, we can't give it to all participants in a study. And that's why we do have to have a control group and a treatment group or multiple control groups, right? The control group in an experiment is the group of subjects who don't receive the treatment, like they remain unchanged. As I said, they receive a placebo. So let's identify the treatment and control groups in this study. So a study divided college students into 2 groups. One group listened to classical music before being assigned a specific task. The other group were just given the task without listening to classical music. Researchers found that those who listened to classical music performed slightly better if they did the task within a few minutes of listening to the music. The 2 groups performed equally on tests completed later. So what's my treatment group? Well, my treatment group would be those who were in the group that was supposed to listen to Mozart before completing the task. So this would be our treatment. Oh, no, I just highlighted the control group. Sorry, that's the control group, right? The group we're just given the task without listening to classical music, that's our control group. And then this group, this top group that was listening to music, that would be our treatment.